Here I've just set up a small demonstration to show the analog to digital converter facilities on the Nano processor, and for this application we're using the Nano 18 just in one of the standard Nano 18 and Nano 28 prototype boards from Basic Micro. I've got one of the Basic Micro shields hooked up to that, and in the case of the demonstration unit, onto that shield I've mounted an LED display 4-digit, and that's connected up to the programmer, the standard USB programmer, and then a small little 1 amp wall walk power supply. So maybe not the ideal setup in terms of sort of power quality and noise generated from the LED display, and for the demonstration just running a very simple program here, and basically all it's doing is first of all, so we can time the A to D conversion, we set port 0 high, then we take the analog to digital conversion and store that in P7 val. After the conversion is complete, we make P0 low, and then we go to a routine that basically displays onto the LED. The source of the analog input for this circuit at the moment is just a potentiometer. So if we look at that program running, you can see there we've got the potentiometer, and that's giving us the reading. There is some noise on there, you've got a little bit of flicker on the last digits, but as I alter the potentiometer, you can see I can vary between 0 and 1024, and you've got that little tiny bit of instability there. If I look on the oscilloscope, then this is actually the measurement of the timing for that analog to digital converter command. So you can see there it's taking 388 microseconds to do the conversion. Now that's just using the standard analog input command. It's taking a direct reading and then coming out with the results. What I'm going to do now is modify the software slightly, and instead of just using ADIN, I'm going to use ADIN 16, and then for the value, before it prints it out, because it's now going to come up with the sum of all those parameters, I'm going to right shift it by 6 basically to divide it to get us back to the standard 0 to 1024. So you can see at the moment that the modification is done to the program, and that's just going down and programming now. Now if we look at the display system again, just waiting for it to download. Okay, so now straight away you can see that it's giving us the same result of before, but it's rock solid. And as I vary the potentiometer, effectively that's taking out all that jitter. And what this is basically doing is taking 64 readings and then just putting all those readings into a word value, so between 0 and 65535, and then before I display them I'm just right shifting by 6 basically to put it back into the original format. But you can see there that it's made a massive difference to the stability. The downside of this is because each time you call that command it's taking 64 readings, is it's now increased the time for the conversion to 7.1 milliseconds. Now that may or may not be acceptable depending on what your application is, and if the conversion time's not suitable, that's the sort of times when you'd use the circular averaging system, because that way you'll still get the smooth result, but it'll basically be giving you a result every so many microseconds as opposed to milliseconds. Anyway, I hope that helps demonstrate that command, and put a note on the forum if there's anything else you need to know. Thanks.